All right, Chapter 1, Lesson 8, the last one for this chapter. Today what we're going to have is different graphs that we're going to be interpreting different information from. So the first thing we're going to do is define linear versus nonlinear. Here's the crazy thing about linear. It has a word inside of it. Do you see that word? Line. A linear graph looks like a line. Okay, makes a line. Nonlinear is basically everything else. Okay, if it doesn't make a straight line, it's nonlinear. So the height of a launched object, that would be nonlinear. I'm going to shorthand just because, there we go. This one over here makes a nice pretty straight line. That one is linear. The x and y intercepts. This is where it crosses the x and y axis. Okay, so over here with the x-axis, looks like it crosses at 1, 2, 3, 4, 5, 6, 7, maybe like, what is that, 7.3? You don't have to get too technical. It looks like this one goes by 10, so that one might be like, what, 17 on the y-axis? Okay, this looks like a 5. This looks like a 1. Line of symmetry is where it's going to look like a mirror. On the other side of the line of symmetry. So when I look at, say, the height of a launched object, if I drew an imaginary line right here, it looks like a mirror on both sides of that. Whereas with the linear one, there's nowhere I could draw a line vertically where it would look that way. I could draw like a horizontal one, a diagonal one, but that's not normally how we do line of symmetry. So usually line of symmetry is vertical only. So okay. There's a lot of definitions to this one, so I apologize. You're going to have to listen to me talk a whole bunch here. A positive function is where the graph lies above the x-axis, and negative is where it's below the x-axis. So it's going to switch as it moves around. So notice here it's positive. Okay, everywhere that it's above that line, it's positive. Everything below is negative, and the graph itself does switch as it moves across the plane there. This next one is the one that's hard for everyone to kind of remember. Oh no, I'm sorry, that's the end behavior. So where it's increasing and decreasing, always read a graph from the left to the right, and then look, as it moves from the left to the right, is it going up or down? If it's going down, it's decreasing. If it's going up, it's increasing. It's going down, it's decreasing. Okay. We're also going to have minimum and maximum values. Now understand that this graph does go up forever, but there is kind of a little bit of a spot right here where it has a maximum. So just because I say maximum doesn't mean it never goes any higher than that. Just that, well, there's a relative maximum. And in this section from here to, well, infinity, it can only go as high as b, even though on the left-hand side, it can actually go on forever. Okay, and then a minimum would be the same. Technically, it can go down forever, but there is a relative minimum over here. So this next one is the hardest one for people generally. I usually start by doing the right one, because again, you're reading it from the left to the right. So as this piece right here continues to the left, is it going up or down? It would be going down. So how you're going to word this is as x moves, or actually here, we can shorthand that. Let me show you this cool thing here. As x goes towards infinity. Okay, it's going towards the infinity over here. Y, since it's going down, I'm going to say it's going to negative infinity. But now look over here. As x goes to negative infinity, so as it goes to the left, now you're going to switch your brain, and I want you to read this graph from the right to the left. We usually go left to right, but this time you're going to go right to left. As it continues to the left, where does it go? Does it go up or down? It goes up. So y is going to go to positive infinity. We usually just assume positive infinity. You don't have to write the plus sign, but if you want to, you can. So, all right, so for your homework, kind of what we're going to be doing is labeling all these different pieces. So what I want you to do is I want you to highlight where is it going up. So positive and negative. If it is moving in a positive direction, I want you to highlight that in green. And if it's negative, I want you to highlight that in red. So let's try that on this graph. As I read it left to right, this first section, it does appear that it is moving up. So I'm going to highlight that in green. Then it starts going down. When it goes down, highlight that in red. That would be a negative. When it goes back up, re-highlight in green. Now it goes down, so highlight all negative action in red. Back up. Now it's green again. The next thing I want you to do, so that was step 1. 2, I want you to label the relative min and maxes. So right here, basically all those places where it turns around, those are going to be relative minimum or maximums. So since this one goes up before it turns around, this one's going to be a R max, relative maximum. Since this one kind of comes down and says how far it can't go farther down. So this one's going to be in relative minimum. That makes this one a relative maximum. And this one down here would be a relative minimum again. Questions there? That is pretty much what I'm going to have you do for your homework. We are going to actually describe the end behavior, so I guess I should write that down. Describe the end behavior. So what I'm looking for here is as x goes to infinity. So as it moves along to the right, is it going up or down? It's going up, so y goes to positive infinity. As x goes to the left, which we're going to call negative infinity, where is y going? As I go left, is it going up or down? It's going down, which would imply negative infinity. So that would be your answer to that number 3 part there.